August 20th is recognized as World Mosquito Day, a day that commemorates the critical discovery made in 1897 by British microbiologist Sir Ronald Ross. While researching malaria and its transmission in Calcutta, India, Ross identified mosquitoes as the vectors of this deadly disease, a breakthrough that earned him the Nobel Prize in Physiology or Medicine in 1902. World Mosquito Day serves to raise awareness about malaria and other mosquito-borne illnesses, emphasizing the significant role mosquitoes play as vectors of these diseases. Mosquitoes are not just pesky, blood-sucking insects with an irritating buzz. They are among the deadliest creatures on the planet. Historian Timothy Weingard, in his book The Mosquito, A Human History of Our Deadliest Predator, makes a compelling case linking the harm caused by mosquitoes to some of the most devastating events in human history, including wars and genocides. Weingard estimates that mosquitoes have been responsible for the deaths of 52 billion people throughout history, nearly half of the 108 billion people who have ever lived on Earth. In October 2016, Microsoft co-founder Bill Gates highlighted the staggering death toll attributed to mosquitoes in a blog post. Data shows that in 2015, mosquitoes were the deadliest animals on the planet, causing 830,000 deaths. In contrast, humans were responsible for 580,000 deaths through violence against each other, while animals like wolves and sharks, often perceived as dangerous, caused only 10 and 6 deaths per year, respectively, an infinitesimal fraction compared to the devastation wrought by mosquitoes. What gives these tiny insects such lethal power? The answer lies in their role as disease vectors. Mosquitoes can transmit infectious pathogens between humans and from animals to humans, spreading deadly diseases such as malaria, Zika, dengue, and yellow fever. Although modern medicine has significantly reduced the mortality rates associated with these diseases, we cannot afford to be complacent. Common mosquito species that pose significant threats to human health include the Culex, house mosquito, Anopheles, malaria mosquito, and Aedes, black mosquito. These mosquitoes continue to be vectors for diseases like Japanese encephalitis, malaria, and dengue fever, which remain public health concerns today. In recent years, the incidence of dengue fever worldwide has risen rather than declined. Several factors contribute to this troubling trend. Firstly, the similarities in clinical and laboratory characteristics between COVID-19 and dengue have led to issues of misdiagnosis and co-infection. In regions where both viruses co-circulate, such as Southeast Asia and South America, as many as 22% of COVID-19 cases may be misdiagnosed as dengue, complicating the management and treatment of both diseases. Secondly, human mobility and migration patterns significantly influence the spread of vector-borne diseases. The global reduction in travel and movement during the COVID-19 pandemic led to a sharp decline in dengue outbreaks from 2020 to 2021. However, as countries lifted restrictions in 2022, human activity and movement quickly resumed, leading to a resurgence of dengue cases. The pandemic also diverted substantial public health resources away from mosquito control efforts, contributing to the increase in dengue cases. Furthermore, the impact of the pandemic on population immunity might be another factor driving the rise in dengue incidence and severity, although further research is needed to fully understand this phenomenon. What exactly happens when a mosquito bites a human? Using a specialized piercing-sucking mouthpart, mosquitoes puncture the skin and inject their saliva. This saliva triggers an allergic reaction in the form of swelling and itching. If the mosquito has previously bitten an infected host, it may carry pathogens and inject them into the next person it bites. In this process, mosquitoes are not merely carriers of disease. They act as amplifiers or incubators. Once a vector-borne pathogen enters a mosquito, it infects the insect's midgut and multiplies, eventually migrating to the mosquito's salivary glands, from where it is injected into a new host during the next bite. Given the enormous threat that mosquitoes pose, why haven't we eradicated them? The battle against these bloodsuckers has been ongoing for decades. To eliminate mosquitoes, which have high reproductive capacities, humans have employed various strategies, from sterilizing them to infecting them with bacteria, shortening their lifespan, and even creating genetically modified mosquitoes. However, Many experts believe that eradicating mosquitoes is not a realistic goal. Eradicating a species, particularly one as adaptable as insects, is nearly impossible. Moreover, not all mosquitoes are harmful to humans. Of the thousands of mosquito species, only about 200 feed on human blood, and only a small fraction of these are carriers of dangerous pathogens. Surprisingly, most mosquitoes are actually vegetarians, feeding on nectar, plant sap, or fruit juices. Some mosquitoes, such as the toxorynchite species, even prey on the larvae of other mosquitoes and do not bite humans. The mosquitoes that people most despise, those that bite, are all females. Female mosquitoes need blood to produce eggs. Despite their short lifespan, usually less than a month, they mate only once but can lay eggs 6 to 8 times, with each batch containing about 100 to 250 eggs. To lay eggs, female mosquitoes must consume human or animal blood, which enables their ovaries to develop. After 2 to 3 days in contact with water, mosquito eggs hatch into larvae, which then develop into pupae within 5 to 8 days, eventually emerging as adult mosquitoes. Male mosquitoes, in contrast, feed only on nectar and do not bite. As insects, mosquitoes play an important role in the ecological cycle, similar to many other animals, albeit at the bottom of the ecological hierarchy. From eggs to adults, mosquitoes are a crucial food source for other animals. Larvae serve as prey for aquatic insects like tadpoles and insectivorous fish, while adult mosquitoes are eaten by birds, frogs, bats, and more. What would happen if mosquitoes were to go extinct? According to an article titled "A World Without Mosquitoes" published in the scientific journal Nature, entomologist Bruce Harrison suggests that if mosquitoes were to disappear, an estimated half of migratory birds would vanish as well. Additionally, mosquitoes might be replaced by other biting insects, such as midges, which could also feed on blood and cause local reactions, intense itching, and even severe allergic reactions, potentially spreading multiple diseases. This could have an even worse impact on humans. Therefore, mosquitoes are like cogs in the vast natural food chain, influencing the entire biological chain. If they were to go extinct, it could disrupt the food chain and trigger a domino-like chain reaction. So, how can we scientifically prevent mosquito bites? First, physical methods such as using screens, mosquito nets, long sleeves, and long pants can help avoid mosquito bites. Fans or floor fans can also be effective. Additionally, avoid wearing dark clothing, keep your skin clean, and try to avoid damp and shady outdoor areas. If avoiding mosquitoes is not possible, chemical repellents containing DEET or picaridin can be used. The most effective way to prevent mosquito bites is to eliminate mosquito breeding grounds, removing all stagnant water sources, old debris, and other potential breeding sites.